Hi everyone, this is the part 8 of statistics for everyone towards data science with R. In this part, we are going to study four types of sampling. The first one is called convenient sampling. We use the results that are easy to get, which is normally is not random. Uh, in a city, in any city, we select all the people in a shopping mall on Saturday, for example, and ask the height of everyone. The second one is called systematic sampling. Put population in some order and select every 13th member. In a busy street in the city, we start from a person we see, then count till select the 13th person and continue in the same fashion until to get the necessary number of people that we wish and record their weights. The third one is called stratified sampling. Break population into groups based on character, then sample each subgroup. In this case, we divide population in a city park into kids under 13 years of old, 13 years of age, teenagers, mothers, and fathers. Then we pick up samples from each group and then record the ages of all the groups. The fourth one is called cluster sampling. Divide population into clusters regardless of characteristics and randomly select a certain number of clusters. Then collect data from the entire cluster. We can consider schools, staffs in big companies, staffs in government buildings, people in shopping malls, people in parks, and so on. Then we select some of these clusters and pick up the ages of all the people in selected clusters. In July 30, 2020, the population of the city of Mississauga, Ontario, Canada was 801,877 people. Using this number, we want to simulate ages, weights, and the heights of all the people. To do this, we use the R coding. We have previously introduced the sample function. The age can take values from 1 to 120 years. And replace is equal to true means that these ages may repeat. The same is true for weight from 10 to 100 kilogram, as well as height from 50 to 200 centimeters. Even the variables can take slightly different values, but the number of observations for all three variables are the same as the number of population, which is 1,877 people. So here we have age sample from this population from 1 to 120 as a age. Replace true means that the this ages from 120 can be repeated. The same from 10 to 100 for weight. The same for weight, for height from 50 to 200. And then if we create the data frame with the three columns, if we steer or got the structure, we will see that data frame with 801,877 observational, three variables, age integer, weight integer, and height integer. Let's see a small subset of data frame DF from rows 30 to rows 37. Next, we want to take 4 different samples from this population. First, the convenient sampling. To get this, we select the first 1,000 people, just a convenient. Data frame from 1 to 1,000. Secondly, for the systematic sampling, we select the first and every 13th person in the street and ask the trig statistics of all and combine their values. For this one, we have b equal to c, x equal to 1 from 1,000, count equal to 1. We have a for loop, and we print what we got. As you see, for this code, we first define an empty vector b and the vector x consisting of 1,000 consecutive natural numbers. Secondly, we add df1, means that the first row to the vector b with the concatenate c function. In the next step, we add 13 to the count and then repeat the process again until the count becomes less than or equal to 13,000. The print function b returns all the 1,000 people. By examining type of, mode, and class of b, we see that all are lists. We can also get the first 9 and last 9 elements by providing the corresponding indices. Notice that list elements are returned in a vertical format. To get the elements in the horizontal format, we use the transpose function to get them in a readable format. Let's do that. Type of B, and we see all our list. If we use the transpose function, B from 1 to 9, and T, B from 1992 to 1000 means that the last 9 rows. So we see that age, weight, height for the first 9 people and the last 9 people. Notice that instead of vectors and lists, we can work with data frame as well. Then the code is as follows. We have the same code, but in this case, we have working with data frame, not the vector. Count 4, and we can see if we have DG or we can have head, 10. We will see that the indices are totally random. In this case, we create an empty data frame and then add the corresponding rows by using our bind function, which we have seen it for matrices before. Thirdly, for the stratified sampling, we break population into subgroups based on ages, then sample each group and take 250 first elements from each group. To this end, we first use the subset function, which we have previously introduced for subsetting a vector. Okay. Subset data frame F with the column age is less than or equal to 12. Subset age greater than or equal to 13 and age less than 20. Subset data frame which age greater than or equal to 20 and less than 60. Finally, we subset the age greater than 60 and less than or equal to 120. We can check the number of rows by dim function, which is in fact returns both of the number of rows and columns. As we see, the columns of all data frames are 3, but the number of rows are different. Then we take sample from rows as with the sample function. The df sample means, in this case, n row df means the number of rows. From number of rows, we sample number of rows means that we mixing up randomly, and we call it shuffle 1, df2, df3, and df4, where n row df means the number of rows of the data frame df. In fact, the sample function do nothing here but mixes up the rows only. The last step is to combine 250 elements from each group to get the 1000 stratified sampling. From each shuffle, we take 250 elements and concatenate to get a vector. And we see the height, we see the weight, and we see the ages. Finally, for the cluster sampling, we divide population into clusters regardless of characteristic and randomly select a certain number of clusters. Then collect data from the entire cluster. We sample 250 indices from each 100,000 consecutive rows up to 800,000 and 250 from the last 1,875 remaining population. Then from this indices we obtain 9 data frame as data frame S1, data frame S2, from this data frames we randomly select 4 data frames and bind them to get a data frame with 1000 rows. Here we have sample, means sample from this 9 data frames. We just randomly sample 4 of them, and we got DH7, DH2, DH6, and DH3. But here where I got already different, because anytime we sample we got different selections. And if we take the dimension, we see that the dimension of the S is 1000 rows with 3 columns. Finally, the head and tail function returns the first and last rows respectively. And we see that the indices of all rows in both tail and head are totally different. I think that's all for this part, and thank you very much for your attention, and see you next time.